Hello, everyone, and thank you for joining us. Today, we'll talk about AI at the edge on how to build models, how to deploy models, and what are the key considerations. By now, you might know I talk a lot about machine learning operations, and open source, how they go hand in hand together, leading our AI portfolio at Canonical, the publisher of Ubuntu. But I'm not alone today. I have two experts in devices or edge at the edge part. Steve?
Hey. Hi, everybody. My name is Steve Barriot. I'm the Vice President of Field Engineering IoT at Canonical. So as such, I'm managing a team of Linux plumbers. So obviously, we're focusing on the edge, IoT, embedded software. And one of them is the one that is down there, like Alex, is one of my definite go-to guy whenever there's a problem to be solved.
Hi, everybody. My name is Alex, and I work with Steve. I manage our Americas team in the IoT Field Engineering Group.
Thank you both for taking the time to join us. I know you have really valuable insight and experience and expertise from actually organizations that we talk to, and I'm very happy to share it with our audience as well. By now, everyone talks about machine learning, about artificial intelligence these days. Whether we think of system recommenders in retail or we talk about Gen AI, which everyone is looking at, I feel that there's a lot of pressure on the AI strategy that companies have. Yet, training models is not the only part of the machine learning lifecycle, and running models at the edge is increasingly becoming a topic from what I've seen and what I've learned. So what is Edge AI? Why do we talk about it? Edge AI or AI at the edge really refers to the combination of artificial intelligence and edge computing. It aims to execute machine learning models on connected devices, and it enables them to make smarter decisions without always connecting to the cloud. It makes their life easier, no? I am curious, did I define it correctly from the edge perspective on what edge AI should be or is?
Yeah, personally, I think so. It's like basically it's determining where AI is going to be the most successful and the most helpful. Sometimes, and many times, it's going to be in the DC environment and cloud environment. But increasingly, we're seeing interest being expressed by clients about deploying some AI at the edge. And again, in the interest of inventing new use cases, like things that are pretty exciting, but also in order to be efficient and serving whatever users that they have even better.
Yeah, certainly. I mean, I think one thing to note here is that everybody has a different definition of the word edge, right? If you talk to the telco folks, they mean something different by edge, whereas if you talk to healthcare people, they mean something different by edge. Retail people mean something different by edge. And I just like to think of edge as basically the part of compute which is closest to the real world. And I think, that means a lot of human-machine interfaces and a lot of data collection. And I think those are both places that are right for AI to be deployed.
Absolutely.
Alex, I think you're really driving into what you were going to talk about, models at the edge and data, how do we collect data, and I really like it. One thing that I've learned as well is that companies are challenged when it comes to AI at the edge or edge AI is really because of the size of the devices. It's not big servers, or at least in my definition, is not big servers with a lot of compute power, but rather tiny surveillance cameras, vacuum cleaners that run around the house, which don't have the same capabilities and they have different constraints that we'll talk about. But why do we care about? And you already mentioned some of the capabilities. Real-time insight, I think, was the initial driver on AI at the edge. But then also reducing costs, because if you think of all the amount of data that we are collecting these days, do you really need all of it? It ends up being stored somewhere and it means money that organizations often are wasting. And this goes hand in hand with faster data processing. I think optimization might be the word of this century. We want to optimize our lives, we want to optimize technology, we want to optimize how do we collect and process data. And what a better place to be than an edge device? Do we need all the data? It's a question that we will ask soon. But then it also increases or addresses the needs of privacy and security, and how do we talk about it when it comes to machine learning. And these days, sustainability becomes important as well. So reducing the power consumption is I think a topic that will come up even more often in the long run. Also, of course, we started with AI on big clusters many years ago, but as we scale machine learning initiatives and as we scale projects, we will need to look at the edge and how do we run models at the edge? How do we maybe build models at the edge as well? Is there anything else that we should care about when it comes to edge AI? I'm looking at both of you because probably you're like, Andrea, you're missing out a lot.
Well, there's a lot to be missed. That's the problem, right? It's like my feeling is that everybody wants to be involved in AI. Many people have good ideas how you can deploy AI at the edge. Some people just don't want to be missing the train, and that's legit. You know, like AI is a disruptive technology, but as part of this, and this is something that we discovered a little bit by accident, like in the edge division of Canonical, we developed something called Ubuntu Core, which was basically created for devices. So you have thousands of devices spread all across the globe, right? So it's slightly different from a cloud environment or DC environment where things tend to be more centralized. So one of the things that needed to be done with Ubuntu Core was to say, hey, we want security, so it needs to be secure by default, but also it needs to be secure through time. And now what you're talking about here is that you need to be able to deliver updates and to be making sure that it's done automatically. And there are nice things like rollbacks just in case an update is faulty. Now, quite not by accident, but maybe serendipity is the right word here. It turns out that OTA mechanism that we developed is also very much appreciated by our growing number of customers that are using AI, because guess what? It's a new field. Everybody is on the bleeding edge. They're trying to figure out new things. And that means that they need to retrain the model pretty often. Like one of our experts internally said, like maybe sometimes every 2 to 3 weeks, they will go through an iteration of a model. Then the point here is that you want to distribute that model, and then we do have a mechanism to do that.
And it's important to mention, and correct me if I'm wrong, that we have a mechanism to distribute the models regardless of the architecture of the hardware as well, right? Like one interesting thing about the devices part or the edge part is that you don't have only one device, which is one type. You might have millions of devices and they're not always the same, correct?
Alex, you want to take it up?
Yeah, we often have people operating heterogeneous fleets with different device architectures, different scales of device, different levels of acceleration available. And one of the nice things about Snaps, Steve mentioned Ubuntu Core, Snaps being the fundamental packaging mechanism in Ubuntu Core, is that a lot of that heterogeneity kind of gets just hand waved away, right? If you provide the resources, all of the updates go over the right channels to the right places to the right devices in your fleet, and you don't have to worry about loading the right thing in the right place.
Now, there is also, sorry, Steve, you wanted to add something?
No, go ahead.
I'll move towards the next slide because I think we're really digging into what are the model considerations. There is also a question on do you really need to update a model? And the short answer is yes. If you just leave a model living there in, okay, not in 3 weeks, but I can tell that in 6 months it's going to be to do more damage than actually good for the project that you had initially in mind.
We hope not, right? It's like sometimes we hope not. We hope that your model is doing what it should be doing, but the problem is that again, the technology is evolving quite fast, and sometimes it's easy to make maybe a mistake or just realize a little bit later on that, well, that model is just not working. It's not doing what it should be doing. And then you do need to have a plan at that point in time to update these models, even if the devices are going to be in the field. Obviously, you don't want to do a recall. That's expensive. So that's part of the reason why many people are coming to see us right now, because they are interested in that update mechanism.
And
no.
to follow on that, right, you have on the side the three components of edge AI, the third one being tools. You know, a lot of the attention right now is on the newest developments in AI and ML, the newest models, the newest training techniques, whatever. But if you want to bring that to the world, there's a lot more than just dropping the model out into the world and letting it happen, right? You need a platform, you need tooling, you need network connectivity, you need all of this stuff that sits underneath that to let you bring that out into the world. And that stuff all needs updates as well, right? That doesn't just stay fixed either. And so you need to be able to use that update mechanism to not just update your model, but everything that allows your model to run in context.
Can we do it with open source? Would be one question that I often get.
Oh, absolutely. That's kind of fundamental to Ubuntu, right? We have quite a bit of experience running this kind of stuff on top of Ubuntu, and Ubuntu is, the trusted source for open source.
And that's a nice thing about Ubuntu, right? It's like, even if you're operating at the edge and say that you're opting in Ubuntu Core, well, it's still open source and it's still Ubuntu. So there's a commonality, there's a lineage between Ubuntu Server and Ubuntu Desktop, what we call Ubuntu Classic internally, and Ubuntu Core. So it's Ubuntu Core being kind of specialized for devices, but it's still Ubuntu. So there's a great deal of compatibility.
Now, one thing that I get questions often about is really security and concerns. And I think when it comes to edge AI, there are even more concerns on, are these devices really secure? What are the risks that we expose ourselves to when we put a machine learning model that is not secured on one hand, on the other hand, on a device that is not secured as well? Can it make any harm to an organization?
Yeah, I mean, many types of harm. I mean, when we are dealing with regulated companies or regulated industries, you're talking about devices sometimes that they can make decisions that could actually cause harm. Or by not being efficient, then it takes the wrong decision, then cause harm. Not going too deep into the details, but like in my car, I have a system that detects if an animal is crossing the street, right? Now, it's not what people think about edge AI, but you would think that you don't want that system to fail at the wrong moment, right? It's embarrassing, but also somebody may die. But even if you don't go to that extreme, you're talking about, for example, if your model has a hallucination, maybe nobody is getting hurt, but egos may be bruised, or maybe that like it's bad advertisement, right? Suddenly you're in the news for the wrong reasons. So yeah, there's absolutely a way to get into trouble with AI if it's not handled properly, or if your security is not top notch.
I also have a question here, and I'll look a bit at the data part as well now. Can an edge device that is not secure give access actually to data which is often sensitive as well. So it doesn't harm you directly, but it can cause data leakage, for example, or other security risks in that direction.
Alex, you want to take that one?
I mean, absolutely, right? Like if all of this is about data, right? There's no point in deploying a model if you're not going to operate on data. And if you're pulling in data and your device isn't fundamentally secure, that is a hole for somebody to come in and grab that data and take advantage of it. So especially in regulated fields, especially if you're dealing with sensitive data, for example, healthcare, right? Some of the most sensitive data. You really, really need to make sure that your device that is dealing with that sensitive patient data isn't the hole where that data is going to leak out of the secure system.
Now, I'll take an example. Sorry, Steve, you wanted to add something?
No, go ahead.
I wanted to suggest we take an example because I think one of the real value that you two have is really talking to customers. And I know, for example, predictive maintenance is one of the typical use cases of AI at the edge, probably. What kind of data do companies accumulate, and do they really need all the data that they collect to build their models?
Yes and no. I mean, look, at the edge, you can really collect tons and tons and tons of data. And guess what? AI is a data hug. Like the more data you have, and the more things you can actually modelize. So you do need a lot of data. However, uh, even with AI, there's such thing as data overload. So like, do you want to transmit lots and lots and lots of data that may or may not actually bring you some value? The answer is probably not. So we do have clients that are thinking, what is the data that I really need to get back into my data lake, and then have some intelligence at the device on the device side to be able to decide, okay, that's the type of data that I really need, and then I can transmit again securely, because security is important, but like being a little bit more picky on that front.
Yeah, and I mean, to flip it around a little bit, right? This might be what Steve was going for, but inference in the AI context can actually be used as a tool to reduce the dimensionality of the data that you're sending upstream, you're storing, right? So instead of having a dumb gateway which pulls in, in the predictive maintenance case, vibration and camera sensors from a bunch of different machines on a manufacturing floor, and just transmits all those raw feeds over the network, stores them all in a lake or a warehouse, and then does the analysis in the cloud. If you do edge inference, you can massively reduce the dimensionality of that data before you transmit and store it, really reducing your bandwidth and your storage requirements there. So.
Yeah, no, that's exactly what I was going for, but your explanation is top notch as usual. Thanks, Alex.
So does it mean that edge AI also plays a role into how we train models?
Yeah, it's a great way to generate data in the first place, right? It's like if you have a model that goes in the field, the fact, like I was working with another company before where they said something about, we're working with automotive manufacturers. And, because of this, every driver is different, right? So your software is going to be exercised a lot of different ways, much, much more than what you can exercise in the lab. Now, again, AI is reliant on having lots and lots and lots of data. Guess what? Deploying a device into multiple locations is a great way to generate that rich fullness of data in the first place. But then again, you do want that to be transmitted securely. You don't want an overflow of data, but you also want that data to remain private. So that's the other challenge.
Thank you. And I think you're right, actually. The way that I see it, and maybe I'm wrong, it's really like a complete cycle. It starts with data that you collect on an edge device. You send it to a cloud, whether it's on-prem or public. You train the model, and then you send the model back to maybe the same edge device. And this happens continuously, and the moment you abandon this cycle, it's likely that something is going to break, whether you end up having tons of data that it's unusable or you have models that are not performing as you expect. There are always risks, and that's why you also need observability capabilities of the model. Of the model of the infrastructure as well. You need model monitoring in place as well, because otherwise you're kind of blindly trying to guess what's happening and how it's happening. Um, Beyond Ubuntu, I do think there are also other open source capabilities that we should think of on. Now I think of I know more about the cloud side. You can train models using open source tools. You can deploy models using open source tools. If I think of Kaiser, for example, it's known in the industry for actually deploying models, or the Triton inference server from NVIDIA as well is probably quite well known. I'm wondering what are the other challenges that companies have beyond the usual identifying the gaps, ensuring the security part, figuring out with the data. I think data is still a challenge overall. They either collected all the data possible and impossible, or they didn't collect any data. They're usually into extremes. Is there any other challenge that you see from the field while you talk to customers?
Yeah, so I mean, I think a big one is identifying a familiar platform, right? Because I think a lot of the personnel who do a lot of this work are very used to working in the cloud environment, because that's kind of where a lot of this stuff was born. And then when you go to the edge, traditionally what you think of as an edge environment is not very much like a cloud environment at all, right? Like a very small, build it yourself, image-based Linux build for the edge. Looks very, very different than, for example, a Kubernetes cluster in the cloud. And I think that making that jump, it's often a skill issue or personnel issue, right? But making that jump from the cloud to the edge can be tricky. And one way we've seen people, and one way we've been able to help people do that, is by making that edge environment feel a little bit more familiar by deploying Ubuntu Core as a kind of an edge operating system, but with a small single node Kubernetes cluster on top of it, micro-Ks, right? There you go, another open source solution, which really helps make that edge environment feel more familiar for people who are used to the cloud.
What about snaps? When do we use snaps in an edge AI use case? Now I know, Alex. We've been also working together, so sometimes I know what you've been working on and I can ask. I'm sneaky.
Yeah, so we can use snaps in both kind of the Kubernetes case and in the native case, right? So we've seen people use snaps to deploy OCI images with models and Kubernetes resource definitions to these single node clusters at the edge. But you can also take that same model, and instead of packaging it as a Kubernetes workload, package it to run directly natively on the host and then deploy it as a snap. So the snaps serve as this kind of single channel OTA mechanism where you can deploy either to your edge K8s cluster or natively at the edge, plus all your other tooling can come through snaps as well. So it's really, really one channel for over-the-air updates of all of these different pieces.
That's what is really interesting from my point of view, right? Like managing what we call Linux plumbers. We have been active in device field for a long time now, and there's nothing more interesting to me when I see my Linux plumbers speaking with clients and basically advising them on different strategies. Because as Alex said, sure, they know Linux, they have been doing things in the cloud, in the DC environment, but in devices, you're dealing with some limitations. Some of these limitations because, for example, you may not even have access to regular power. Maybe you own battery for what it's worth, right? Or because it's going to be deployed upon thousands of different systems. So even if you're saving a little bit of money by going a little bit cheap on hardware, well, it's worth it because overall you're going to be saving a lot of money. Now, because of this, sometimes people, again, coming from that server environment, may not realize all the challenges that they have. But this is where we come in and we say, well, we have seen it before. And based on your plan, maybe that we can recommend a few tweaks that are going to make you more successful in your edge endeavors.
Steve, I think you're really raising a very interesting point that actually the challenges that organizations face at the edge are often completely far from what people almost in the cloud would think of, like having no network accessibility, having not enough space on the device as well, like the storage itself is small as well, having devices that are of different types as well. Like when it comes to the cloud, it's usually one cloud, one architecture, super easy. I remember when I first actually learning about Edge AI, these were the three things that amazed me of normal for the edge, yet nothing that I could think of initially.
That's every day. it's a little bit of evangelization, but it's an interesting part of being part of Canonical enough that device team, because we can help. That's what is really good about it, and that's something that all of my team members absolutely relish.
So now, if we talked a lot about the challenges when it comes to the solutions, for me, I always said it needs to start with a use case. Don't do AI at the edge just because of any reason, and don't do AI in general just because you don't want to miss the train. Identify the use case that helps you out, that could help your company, your organization, your devices to better perform, and only after that, think of how edge AI should work for you. Then it should go, and we should look at security, right? Security is the heart of everything. Secure your device, secure the platform where you're training the model, secure how you're deploying and packaging the model, because otherwise, sooner rather than later, there are going to be challenges that you'll have to face. And running it in production when it's not secure, it can turn into a big challenge. Should I ask, why do we care about secure boot? That was, I had some months ago, an interesting educational session with Steve and Alex on what is this edge? I need to learn more. Secure
Sure.
boot was one of the things that they told me about.
So one of the major differences, and we've touched on this a little bit already, but one of the major differences between a machine running in a cloud or a data center and at the edge is that when it's in the cloud or in the data center, it's not within your estate, either within your physical property or within your network firewall, right? Which makes the device that much more vulnerable to bad actors. This could be a robot in a retail store, and it could walk out the doors and someone could pull the hard drive. So why we really care about secure boot is because secure boot, a verified boot chain paired with a robust disk encryption solution, means that even if someone has physical access to your device, which they will in the edge environment, and can remove the storage, they won't be able to gain access to the data on the disk. The operating system will only boot kernels, but even user space workloads that have been validated and signed, and without that operating system, without that operating system being the thing booted on it, the disk won't unlock. And so the data, both your proprietary workloads, your models, but also the data those models are operating on, are not available to somebody who might be, even if they have physical access to the device.
Yeah. I mean, one of the key differences is exactly that. Help is not nearby. Like in a DC cloud environment, you do have engineers lying around, and then if there is a system that acts up, chances are that you're probably going to be able to detect it. If you get hacked in the field and you don't have the proper systems in, and it's a device somewhere, like I even had a prospect coming to me and saying that his devices are going at the top of Swiss mountains, and it takes a day just to climb there to repair the thing, right? If it gets hacked, it's much less likely you're going to realize it. And then remedying the problem may also be even physically much more complicated. So that's why security is important in the server world. Make no mistake. It's even more important in devices.
I think third thing that is important in devices, the OTA mechanisms. You can update models, you can update devices, you have the auto rollback in case something fails, and at some point it will, whether we like it or not.
Yeah,
Sometimes it does.
I always tell people in trade shows, people make mistakes, and what happens next, right? Is like you made a patch available, then say Ubuntu core tried to update itself. If the answer is that you made a mistake and then the system crashes and then you have to send somebody to reboot or reflash, even worse, well, that's problematic. Uh, so the on the OTA mechanism, we do have a rollback capability, which is basically it's embedded in our snaps and saying I'm going to try to run that new version of the snap. If I can't, it's going to default back to what it was before. So the patch is not there, but at the very least, what you don't have is an expensive paperweight in the field, which you absolutely want to avoid.
Yep.
And
the modularity of the packaging as well really contributes to that. On a traditional Linux package-based system, with everything kind of intermingled in a single root file system, the same set of packages installed to a device can, just given a slightly different order of installation, cause radically different bit-for-bit file systems, which is not a huge deal when you're logged in and you're a sysadmin, but is a really big deal when you have 10,000 devices in different environments across the world. You will start to get variations in your fleet. Whereas with snaps, since it's a modular system where everything's not installed to the same root file system, but each package is set down in its own little place next to each other, you install the same 10 snaps on 2 devices, you get the same bit-for-bit file system, no matter which order they were installed. And so it reduces it also, in terms of making a more robust OTA solution, it reduces the variations across your fleet so that once you test an update in your lab environment, you can be much, much more confident that you're actually testing this against what looks like what will be your real devices in the wild, as opposed to something that could theoretically be one permutation of your devices in the wild, but is not likely to be every single device that you actually have deployed.
Yep.
that's a good point. And then if you look at the edge side as well, it's important to have support for different types of architectures, as well as networking support. And last but not least, using open source tooling, and I briefly asked about it and talked a bit about it, is really to be able to train your model, deploy your model, ensure that the OS has security capabilities and kind of the same capabilities with open source. You can do it all with same tooling, same capabilities, same experience as well. Which, if you look at least on the machine learning side, there is a talent gap on the market. Now, if we want to find also machine learning experts at the edge or edge experts with machine learning skills, we're just shrinking more and more. So having or enabling people to use the same tools, same experience is important as well. Now, being also cognizant of time, I'll mention this, that with open source and with Canonical, you can experiment and get started on workstations with our tooling, but then you can train models in the data center, whether it's on-prem or on cloud, on different architectures, and then you can deploy them on different types of edge devices. It's a pity we couldn't talk more about some of the user stories that you have. I know whether we talk about telcos or logistics, we have some interesting case studies, but I also know some of them are going to be recording in some of the future events that we have. You can, of course, with open source deploy models, store your data first of all, because any device generates data and that data needs to be stored somewhere. Whether we talk about SQL databases, NoSQL databases, it needs to be stored somewhere. And then you train your models, of course, you get insight, you get visualization, you store your features, and you run the entire machine learning lifecycle using one solution. In the end, you deploy your model, but that doesn't end there. It's important to mention once again, you always update your model. You monitor it and you update it such that it stays up to date, because data changes over time. Remember, in retail, you could see how data shifts depending on season, for example. Retailers sell more in specific months than in others, and in specific seasons rather than in others. And it's the same with any type of data. If it's a surveillance camera, nowadays you will have old cars, and in 2 years, people are getting rich and they have new cars, and your model might not recognize them anymore, for example. And that's how it all fails.
Well, what you're saying is that life is dynamic, it's not static. And because of that, your models are going to have to continue to evolve. Hopefully, maybe less after a certain time, like there's a certain stability, but perfect stability is never going to be achieved because as a society, as industries are just evolving, there's a lot of things that will have to be retrained. That's at least my opinion about this.
That's a good thought. Alex, do you disagree or agree?
No, certainly. I mean, if we look at even the state of AI/ML now compared to a year ago, 2 years ago, things have clearly progressed rapidly. And so I can't imagine how we'd expect this to not continue progressing over the next year, 2 years, 5 years, decade.
Yeah.
And I think the beautiful part with Canonical, and of course we are biased because we are part of Canonical, but is that you can really do all these things with us and with open source tooling, whether we talk about training models, tracking experiments, storing models, or we talk about securing the device, packaging the model, deploying models. You can do it all with the same tools, all open source, same capabilities as well, and get the same level of security support, help at the end of the day, which we all need every now and then. Is there any thought that you have for the AI of tomorrow? That's what I usually ask in my podcasts. Now I'm stealing this. How is edge AI going to look like? What do you think?
I have a thought. I think we spend a lot of time talking about inference, and I think edge AI today is super focused on inference. And we talk a lot about gateways and gathering data, and that's a big part of our market. But we also see a lot of people who do spend a lot of time working on human machine interfaces, HMIs as we call them, for dealing with, for kiosk style interfaces, for everything from DNA sequencing machines to coffee machines, right? And I think we're going to start seeing the other half of this, which is Gen AI being introduced into these user interfaces more and more and more. And so we're going to start, we've seen a lot of inference coming to the edge, but I think we're going to see a lot of Gen AI coming to the edge as well in the next, the AI of tomorrow, at least when it comes to the edge, is going to be Gen AI at the edge for human machine interfaces.
No,
I
I'm
can't
scared.
agree more. And it's exciting too, because you know what? So far, when I'm speaking with my car, for example, I know that the capability for the car to actually understand what I'm saying is limited, right? There's a few prompts that you need to hit, and that's it. It won't try to really understand what you mean. Now, wouldn't it be great if instead of just memorizing these prompts and saying, well, I need to use exactly these terms, I could actually just talk and say, like, that's what I want to do, instead of worrying that I'm hitting the wrong words. Now, like that's not for tomorrow, but that's certainly something that our friends in the OEM and the tier one suppliers are really thinking about right now, because that will be valuable for users.
And before it comes to cars, it'll come to, as I said, coffee machines, right? You'll, instead of going up to your coffee machine and hitting the little icon on the push button thing, you'll have a conversation with a virtual barista, and then your coffee will come out, and it will be more of a natural language conversation than a traditional kiosk interface.
Correct. Yeah. So the Jetsons are coming. That shows my age. Sorry.
Well, I'm the skeptical one usually, and I tend to say that let's see. I think there is a long path until we get there, but I see it happening. To be fair, even if I would like to say no, I see it happening, and I see it being adopted much faster than we imagine, actually, because we already have a lot of appetite for AI. We have a lot of appetite for AI at the edge, and there's a lot of investment and research going on as well.
Absolutely.
Maybe our next webinar will be about exactly this topic. Who knows? we're also happy to get ideas maybe from our audience as well. But that was it for today. Thank you, Steve. Thank you, Alex, for joining me to talk about AI at the Edge.
Thank you for the invite.
And if you want to use it, I think you should use it with open source tooling, right? That's my usual message.
Absolutely. Thank you very much, everybody.